In this video, we are taking a cantilever beam, a simple representation, and a numerical problem. So for this simple representation, I am taking a cantilever beam which is fixed at one end, free at other end, and having a point load at that free end. So as this is cantilever beam, fixed at one end, free at other, whatever the load carried by this that that load will be ultimately shared or carried by this single support. So that fixed support will carry entire load on this cantilever beam. So let us try to calculate the shear force directly. For this shear force, let us come from right to left. Okay, we have this point load W at this point B. So shear force at B. So actually shear force can also be represented by F at B. So that is only load we have according to sign convention. So for example, I'm creating a section here. According to sign convention, this downward load will be positive. So you can just refer my video on sign convention of SFD and BMD tag. And if you see, there is no load exists in between A and B. So that load will be continued till A. So let me draw the shear force diagram. So here I am extending these support lines. So this is A, this is B. So we have this shear force W, positive W, and we do not have any load in between, so that load will be continued up to here. So that is what the shear force is, and this we say that is a positive shear force. And we need to calculate the bending moment. So bending moment can be represented by Bm or M. I will be telling you while solving the problem. I will be talking more about shear force and bending moments. So as of now, you see, moment is actually force multiplied by perpendicular distance, force into distance, right? If you see this moment at P, so we have moment at load at B, but there is no distance. The load itself is acting at B, load is 0. So so can you just remember, so what kind of what kind of bending moment sign convention it will be? So it is hogging, right? So whatever the load, if you apply on this cantilever, if it will bend like this. So this is hogging, it is bending like this. So you see it is crying. So we, as per our trick in the previous video, that is negative bending moment, right? Hogging, negative bending moment. So cantilever carries the negative bending moment. The bending moment at B is 0. Okay, however, yes, we have the load, but the distance is 0 because the load itself is acting at B. There is no distance up to B, right? So now we need to find out bending moment at A. Now we need to calculate all. This is when we are talking about the beam and bending moments. So wherever the point we are considering, we need to take the sum of moments up to that point where what we are considering. So bending moment at A. So we have only load and we need to consider distance up to A. Load multiplied by perpendicular distance up to the point we are considering. So we are considering the point A. So this is the negative bending moment crying. So this load will cause the beam to bend like this, which is hogging, just like this, minus W into L, minus WL. So it is having some magnitude, negative magnitude, right? So we will try to draw the shear force bending moment diagram. So this is shear force diagram. So let me draw the bending moment diagram. This is A, B. So we say it is said the bending moment at B is 0 and at A it is minus W into L. And that way can be joined by a single line. This is absolutely the negative bending moment. This is bending moment diagram. So if we solve a problem, you will understand it better. So for that, we shall take a simple example. So here this is the problem. A cantilever of 2 meter carries point loads as shown in the figure. So for that we need to draw the shear force diagram and bending moment diagrams, right? Okay. So if you see the diagram, so you can see the shear force with definite loads. So for this we need to calculate straight away. We shall start with calculating the shear force. shear force at B. So, or I can say simply FB. Can you tell me what is the load here? This is 800 Newton as according to sign convention. So this is here my section is, this is positive 800, positive 800 Newton according to sign convention. And shear force at C. So when we are calculating shear force at C, so we need to take the sum of loads at up to the point C. So shear force is nothing but sum of loads right or left to the section. So we are coming from right to left, so we have to move our sections wherever the point we are considering. So here we are considering the section at the first move, so that is 800 Newton, and we are shifting our section at C, that is we have two loads, 800 downward, 500 downward, both are downward and both are positive. 800 plus 500, so that is 1300 Newton. And FD, so how many loads we have? 1 2 3, all are downward, 800 plus 500 plus 300, so that is 1600 straight away, 1600 Newton. And at A, so that shear force at A, there is no load in between that, so that 1600 will be continued up to there. Let us draw the shear force diagram. You can understand it better if I draw this. Okay, let me draw the reference line. So we are about to draw shear force diagram. So all the points, let me mark it as mark them as A, B, C, D. So if you see, so directly without looking at these values, we can also directly draw the shear force diagram for this cantilever beam. It is very simple. Just see. So the load at B is for 800 Newton. That is the shear force at 800. So that is okay. There is no load in between B and C. So that load will be continued up to C. So that is 800 Newton. So at point C, what happens? Suddenly 500 Newtons are adding. So you project it to 500. So that is how much? 800 plus 500, that is 1300. Yeah, there is no load in between C and D, so I have continued up to there. So at D, what happens? Suddenly 300 Newtons is being added. So 300 Newtons. So there is no load in between D and E. That load will be continued up to A. So that is how much? 1300 plus 300, 1600. That is what we have just calculated, right? So all this is positive shear force. This is positive shear force. So we need to calculate now the bending moments. So now bending moments, if you just a minute. Now bending moments. So let us come from again right to left. So now I'll say bending moment at B. So we have load at B. Okay, how much? 800 Newton. But there is no distance. 0. And it is hogging, so all the loads are acting downwards and causing the beam to bend like this. So if we take, so as we are coming right to left, we are taking sections like that, so the beam will be bending like this, right? So here if you see, there is no load, so simply this is 0. Here bending moment at C. So if we see, we have 2 point loads and only one distance we have to consider. For example, so uh, this is the load. Yes, as we said, the this is the sum of loads, sum of moments. So we have up to C, we have the load 800 multiplied by the distance up to C. How much that is? 800 multiplied by 0.8, and this moment at this point it is causing the moment like this. Okay, again hogging. This is trying negative bending moment. So bending moment at C, this is minus 800 into the distance up to C, because we are calculating moment about C. So that is 0.8. So that is how much? 640 minus 640 Newton meter. That is very important to mention the units. Now, so if you see 500 multiplied by 0, because there is no distance up to C at the 500, right? So we are neglecting that. Again, so if so you'll get clarity if we find out bending moment about D. Okay, this is 800 multiplied by distance up to D. How much? 800 into zero point 0.8 plus 0.7. So that is also negative bending moment. 800 into 0 0.8 plus 0 0.7 minus another bending moment is also negative. So this point load, that is 500 Newton, and distance up to D. We are calculating moments about D. 500 into 0 0.7. 500 into 0 0.7. So if we calculate, we will get it as minus 470 Newton meter. Now bending moment at A. So here if you see the bending moment, so we have three loads, three distances. So let us come from right to left again. 800 multiplied by distance up to A. So that is nothing but minus 800 into distance up to A is 0 0.8 plus 0 0.7 plus 0 0.5. That is nothing but 2 meter. Okay. Minus another 500 into distance up to A. Minus 500 into zero point 0.7 plus 0.5. Again 300 into minus 300 into 0.5 distance up to A. So we will get it as minus 2315 Newton meter. So this is so we have calculated now the bending moments. So let us try to draw the bending moment diagram. So this is will this here will get negative bending moment. So let me draw the reference line here. A, B, sorry. Okay, if you draw, so this is bending moment at B is 0, so 0, and bending moment at C is minus 640. So at C minus 640, I will note it as minus 640 Newton meter, and here bending moment at D is 470. So at C this is 470. Sorry, this is not correct. So this is 1200 minus 1200, and this is 350. So finally we will get the value as minus 1550 Newton meter. Please please see the calculation. Sorry for that mistake. So here that is bending moment at D, right? Minus 1550 minus 1550 Newton meter, and here bending moment at A, finally that is 2350. And if you here I want to tell you the relation between this point bending moment diagrams. So when you are connecting from point to point, if you see bending moment, what I said, so bending moment is nothing but the force multiplied by the distance. So if for example let me say x, so distance is varying, right? So let me say force multiplied by the distance. So this is like just like the form y is equal to mx. That is nothing but it is a straight line equation that represents straight line equation. So whatever the points we got, so we have to join them with the straight line. So that is its meaning. The relation between these points is the straight line relationship. So I'm connecting with all the points with the straight line, and this is negative bending moment. There is a force into perpendicular distance, y m is equal to f into x, that is nothing but that is in the form of y is equal to mx, which is a straight line equation. So the relation between, or the draw Yeah, relation between all the points will be like straight line. This is the negative bending moment. So this is bending moment diagram. So that is about the simple problem on shear force and bending moment diagram of cantilever beam, a simple numerical problem. So in the next class, we will be seeing with different loads of this cantilever beam. Thanks for your time.